Welcome to problem 438 on page 143. In this particular case, this is again a regression equation. So the first thing before we start Excel is to determine which are our x and y variables. So if you were to plot this on an XY graph that you've seen many times, what would you put as the x-axis and what would you put as the y-axis? It should hopefully be fairly obvious that the new car registrants is the x-axis and the sales tax is the y-axis. In other words, the more car registrations you have or new car registrations you have, the more your annual sales collections will be, not the other way around. So in this particular case, we go to chapter number 4 again, regression. The number of periods in this case are 7. There are 7 periods of time. All right. So we go OK. Now I'm going to label this. So the periods of time are 1 through 7. So the demand is the sales tax, just to make that a little bit more clear. And this is new cars or new vehicles. So we put in the data and pre-populate this. This will only take a moment. 1, 1.4, etc. And you can use the copy and paste feature from your Excel OM. All right. So the regression equation will look like this. You would have negative 0.158 approximately plus 0.130837 x. So in this particular case, that's your regression equation that you have. So I'll give you just a moment to take a look at that. So what that represents is if there are no new car registrations, there'll be actually negative tax collection, which is not possible. So the y-intercept is not all, it's an estimate. So that's actually not an accurate number. But for every car, though, you would have 0.1308 increase in your revenues. Now, these are in thousands. All right, so you can adjust it, but I'm simply going to put in the dark shaded area in C19. I'm going to put in a 22. This is for part B, by the way. All right, and so the forecast would be 2.72, and those are in millions. So if there's 22,000 cars, you would have $2.72 million in tax collections. So in part C, you are given the coefficient of correlation is right here. So this is the answer for C at 0.966 for 89. And the coefficient of determination is 0.934101. So it's already done for you, which is a lot easier than probably the way you took in the statistics. So there's the answers for the 3 parts. We've calculated the regression equation. We've calculated the forecast at 22,000 cars, new registrations, and then we've already got the correlation, the coefficient of correlation, coefficient of determination already done for you. What those do is they tell you the strength of the model, how well the model predicts, So this is very strong when it's over 90%. That tells you it's a very good model for predicting car sales. If there's only a few percentage that is not predicted by this model,